implicit differentiation. So you know that means anytime I see a y, it's a function inside. This is nice because as soon as I take the derivative, I get to plug that number in, or those numbers in. Derivative of x is 1. Derivative of y is y prime. The derivative of negative 1 is 0. Equal 1 over x squared plus y squared. Derivative of ln of stuff is 1 over stuff times the derivative of stuff. And you see that. Now let's go plug in x equal 1 and y equal 0. So nothing much happens over here. X equal 1 and y equal 0. Well, that all just gives me a 1 times 2. And then, oh my goodness, if I put in 0 here, that's just 0. Well, what am I left with? So I have 1 plus y prime is equal to 2. So y prime is equal to 1. Is that all? One last thing. They want the equation of the tangent line. There's our slope. There's our point. So y minus 0 is 1 times x minus 1. Okay, so this one wants us to find the particle's path and the distance covered. So if I want to find out where it's at time 0, I put 0 in. So I get negative 1. If I want to find out where it's at the end point of 2 pi, I plug that in. Oh, look at that. I get negative 1 again. All right. I know in between there's probably a place where the velocity is 0, where it changes direction. So take the derivative of negative cosine is sine, and then plus cosine of t, set it equal to 0. Oh, we've encountered this many times, where they're the same, the cosine and sine are the same number but opposite signs. So that's going to be 3 pi over 4 and 7 pi over 4. Whoops, I almost broke 5. 7 pi over 4. So then it's my job to find out where it's at those 2 points. So s of 3 pi over 4. So if I put that into here, I'd get, so cosine of 3 pi over 4 is negative, so that would give me a negative root 2 over 2. Sine is root 2 over 2. Oh, look at that. I get 2 root 2 over 2s, so it's root 2. So then if I do the same thing with 7 pi over 4, s of 7 pi over 4, so I know that the cosine is going to be a positive, so with the negative in the front, and then sine is going to be the negative. Oh, will you look at that? Negative root 2. Okay, so what does this mean? So I'm going to draw the number line, and I'm going to draw these points, right? So I've got negative root 2, negative 1, and here's root 2. So those are the 3 numbers that I've got, right? Root 2, negative root 2, and negative 1. So I start at t equals 0. So I'm going to put the little dot there, t equals 0. Then I move to the next time, which is 3 pi over 4. So I move out to here, and I put the time of 3 pi over 4. Then I move to the next time, which is 7 pi over 4. So it's way back here. So t equals 7 pi over 4. And then finally, I move to 2 pi. So right here is t equal 2 pi. So it's my job to find the number of footsteps covered, right? Okay, so from here to here, that total distance would be root 2 plus 1, right? Then, if I go to the next one, let me try different color here. So I want light green. Okay, from here all the way back to here, that distance would be root 2 plus root 2, right? Because there'd be a total distance. And then the last little bit would be here to here. And so that would be the distance between these two. So, oops, I'm going to say plus, not parentheses. Plus, whoops, come back. Plus, and then I would say 1 plus root 2. 1 plus root 2. And then we could add all those things together. So let's see, this and this give me a 2. And then I'd have 1, 2, 3, 4 root 2s. There it is.